Hi, my name is Justin Carruthers and I'm the lead instructor here at Tulsa Welding School. Today I would like to cover the ice machine or ice maker. And today we're going to be going over the fundamentals of it, how it works, and some issues you might come across and how to fix them. So right out the gate here we've got our ice cube maker. So our water is going to be actually flowing down from here, water falling down these cubes. And this right here has got Freon flowing through it, and it's actually removing heat out of the water, allowing it to freeze to these cubes. And then once it reaches the end, the leftover water that doesn't freeze to the ice machine actually goes down into our tank here and gets recirculated. So the flow continues to flow until this thing is completely a solid block of ice. And then there's a little ice sensor that will actually let us know when our ice thickness is at the correct depth, and then it'll go into a hot gas cycle. And what that is actually letting hot gas off of our compressor to flow through here and melt the ice just a little bit so that it'll actually fall down into the ice bin and it will break and bust into small little pieces that we use every day in our drinks. We'll jump over here to more of our electrical side of it. We've got our control board, and this tells us everything that's going on depending if we're in hot gas defrost, or if we're in normal function, or if we just need to do a cleaning cycle on this machine. We have our capacitor here, which helps get our compressor running. We have our Freon, which is where we would hook our gauges up. It's up here at the top to check our refrigerant levels and make sure this equipment is doing its job appropriately. Back here we have our compressor and all of our copper piping, our filter dryer, and different things to help move the refrigerant through the system to create ice. And then on the other side we have, well, where does all this heat go that we're moving out of the water, right? There is a spiral on the back of this that is a tube within a tube. So you'll have Freon flowing through one tube, and there's another outer tube on top of it that has water flowing through it. So this is a water-cooled ice machine. So there's no heat escaping out anywhere. It runs through the water and out the drain. And then on completion, there is a little switch down here. So when this thing gets full, the ice it has nowhere to go. And there's another little magnetic door switch right here that actually lets the control board know that this ice machine is full, and it'll shut it off. On average, you can get ice production in about anywhere from 5 to 10 minutes. Usually, and sometimes it can take up to 15 minutes for a complete cycle. So that is freezing the ice, melting it from the cubes, refilling with water, and starting the process all over again. Ranges between 15 and 20 minutes. It depends on the size of the equipment. Some of these things can make up to 5,000 pounds of ice in a 24-hour period, and some of them make 500 pounds. It just depends on the type of equipment you're dealing with and the bulk environment you're in. There's Olive Gardens out there, or Chili's, restaurants that need a lot of ice. QT's is another great example of places where ice is needed, and you need to size the equipment for the job. Things that can go as far as that may need servicing. Again, we always need to hook our gauges up and make sure this thing is producing ice correctly. We can check our thickness and our water clarity, making sure our water is clear, clean, and has the correct thickness or bridge of ice, but from cube to cube. We can actually tell a lot about this machine just based off the ice clarity and the thickness of the bridge. One thing I'd like to also discuss is a potential service call that you might come across out in the field is going to be that water-cooled system as far as removing heat out of the refrigerant. So you run your water through a filter, and it's supposed to clean the water as best as it can to prevent any scaling, but nothing's perfect. So you may have to actually remove that and put in a brand new one due to scaling, because it basically creates an insulation around your refrigerant tubing, allowing you not to remove heat off of the refrigerant. So that is one common thing that not common, but a potential problem you could find, and the solution would be to probably just remove it and let's put a brand new one in there to give the customer another good 5 to 10 years of good quality ice production. And then one other thing I'd like to touch on is our ice thickness and how we gauge that. So a funny little thing is actually we use a drill bit. It's a 5/16 drill bit, and you'll actually run it across your ice machine, and on this sensor, you want a 5/16 distance between this and your cube maker. And by doing that, you're assuring the appropriate thickness of your ice, which will lead to good quality ice that your customers should hopefully enjoy for a long time. Another fun fact for your ice machine. So let's say your ice cubes are a little bit milky or they're just a little bit off. One of the possible causes of that would be a dirty ice machine, right? So one thing we use is a nickel safe cleaner. You actually will set this machine into its clean cycle, and you will add your nickel safe cleaner into the ice machine, and it'll actually trickle through there for about 30 minutes to get all of the any contaminants and dirt and debris, anything that's built up in that could be from the water or just through the air. And after we get done with doing that, we'll run it through another cleaning cycle where we'll add sanitizer, because we want to have sanitized, clean water or ice for consumption, right? That's one other tool that we use to provide good quality ice for your customers and for consumption. And this is a brief overview of the ice machine and how it works, functions, and different servicing options you may or may not have to do out in the field.